Lesson 4 of Chapter 2 is on long division of polynomials. So let's start by taking two polynomials and dividing them using long division. So we're going to begin with this function right here being the dividend, and this function right here being the divisor. So the divisor goes on the outside. The dividend goes on the inside. And you can see on this dividend, we're missing some terms. There's no x squared term, so I put a 0x squared. There's no linear term, so I put a 0x. And now we're all set up to do the long division. So we start off by looking at the first term of the divisor, the 2x squared, and we ask ourselves, what times that gives us the first term of the dividend, 2x to the fourth? And so that is just x squared, so we put an x squared above that 2x to the fourth. Now we're going to take that x squared and we're going to multiply it by everything in the divisor and write it underneath. And now we have to subtract this from every term above it. So you can see the 2x to the fourths are going to cancel out. And then we have to take negative 1x to the third minus 1x to the third, which gives us negative 2x cubed. And then we take 0x squared minus 1x squared to get negative 1x squared. Again, you got to subtract each term from the term above it. Bring down the next term, do it again. What times 2x squared gives us the negative 2x to the third, right there. So that is a negative x. So now if we take negative x times 2x to the second, we get a negative 2x cubed minus x squared minus x. Now we have to subtract each term from the term above it. These cancel. These cancel. And we'd end up getting positive 1x when we take 0x minus a negative 1x. Bring down the negative 2. This represents your remainder. So we take the remainder and we put it over the divisor. And so this is our quotient, the answer we get when we divide those two polynomials. So next I want to talk about the remainder theorem. And the remainder theorem says that if you take a polynomial and divide by x minus k, now usually there's going to be a number where that k is, like x minus 2 or x plus 1 or x plus 4 that we're about to do in just a minute. If you take a polynomial and divide by that, then the remainder is simply f of k. So you can see on example 2, we're given this second degree polynomial. And if we divide by x minus 2, what's the remainder? Well, we can do this the long way and use long division to find the remainder. We'd put a 3x on the top. That's going to give us 3x squared minus 6x. Subtract those, and we get 13x. Bring down the negative 20. We put a 13 on the top. Multiplying that gives us 13x minus 26. Subtract, and we get a positive 6. So this is the remainder when we take that second degree polynomial and divide by x minus 2. But using the remainder theorem, it simply says that if you're dividing by x minus 2, you can find the remainder by just putting 2 into the function. And so if you put 2 into the function, that's going to give us 4 times 3 is 12, plus 14, minus 20, which gives us 6. You can see this yields the exact same answer. Okay, so if we're asked to divide 3x squared plus 7x minus 20 by x plus 1 and find the remainder, all we have to do is put negative 1 into this function. And if we do that, let's see, that's going to be 3 minus 7, which is negative 4. Negative 4 minus 20 gives us negative 24. And if we're going to divide by x plus 4 and we want to find the remainder, all we have to do is put negative 4 into this function. And let's see here, that would give us 48 minus 28 minus 20, which would give us 0. So you can see that if we take 3x squared plus 7x minus 20 and divide by x plus 4, we get 0 for a remainder, which means it divides evenly. This leads us into what's called the factor theorem. If you get 0 for a remainder, that means what you divided by is a factor. So we can use that on this example here. It wants us to show that x minus 2 is a factor of this third degree polynomial. So the easiest way to do that is to divide these and see if you get 0 for a remainder. Now I want to teach you guys synthetic division. So if you're going to do synthetic division, if you're dividing by x minus 2, you put a positive 2 in the box. You list out your coefficients. Leave a little space underneath those numbers and draw a line. And now we take this first number, the 1, we bring it down below the line, and then we multiply that by the number in the box and put it on the next column. Then we add those together, and then we do this again. Multiply and add, multiply and add. So I just used synthetic division, and I divided those two polynomials. So here's my summary statement. If we take x to the third minus 4x squared plus 3x plus 2, and we divide by x minus 2, that gives us an answer of x squared minus 2x minus 1. So hopefully you can see where I'm getting these coefficients from. Those resulting coefficients from the synthetic division give us the correct quotient. Let's try one more here. Here we have a third degree polynomial. We're going to divide by x minus 3. We can use synthetic division for this, so we're going to put a positive 3 in the box. Again, pro tip here, if you're missing terms, make sure you put a 0. Like if we were missing an x squared term, we'd want to put a 0 where that negative 3 is. We're not missing any terms here, so we can set it up like this. Bring the 2 straight down. Multiply it by the 3 in the box. That gives us a 6. Add those together. It gives us a 3. Do it again. 3 times 3 gives us 9. Add those together. We get 4. Multiply that by the 3. It gives us a 12. Add those together. We get a 0. So you're not always going to get a 0, but that number at the end represents your remainder. So here's my summary statement. 2x to the third minus 3x squared minus 5x minus 12, all divided by x minus 3 gives us 2x squared plus 3x plus 4. So that is synthetic division. And I think that wraps up all I want to talk about for today. Be awesome today.